So thank you, everyone. First, I would like to thank the organizer for this night conference and to give us the opportunity to present you what's new regarding tomography software at the European Synchrotron. So I will first explain you why we have different new piece of software, then the design we picked in order to ease processing, then some details regarding the three main bricks which are visible from the users, and then I will try to explain you what's next. Okay, so let's start with why do we have new software at the European Synchrotron? We went through this extremely brilliant source upgrade that I guess you heard about, and then this brings new opportunities for imaging / tomography, and that we want to benefit from. And at that time, there was already some existing software like PyHST2, which was well known by the community, but which was not so easy, I would say, to improve and add new features and things like this. We were using spec and EDF files for the acquisitions. Now we moved to Bliss, as it was mentioned on the first day. And there was also several scripts which were spread over different beamlines, which were difficult to trust, to know which version they were using, with which features, etc., etc. A well-known script was FastTomo. It was computing center of rotation and calling PyHST, for example. And those was things that we wanted to move forward. So what we decided to do, to go for this kind of structures. Now we have three main blocks which are visible from the users. The first one is NX-tomomil that I will detail, but the idea is that it will normalize the input for the downstream processing. Then we have Nabu, which is kind of the replacement of PyHST, but it adds more features to it and improve the design as well. And then we have Tomware, which can interconnect the different processing together and provide some graphical user interface. So then scientists can define their own workflow and reconstruct their data. Okay, so this is now NX-tomomil. So as the name is probably a big hint for you, the idea is that it will produce NX-tomo, so default NX-tomo from the Nexus application. So this application basically ensures that we will get all the information that we need to reconstruct data as rotation angle, frames, frame types, energy for Paganin, and things like this. So this is one NX-tomo that we are producing and that we will reconstruct a bit later, displayed by SelectView. So the idea clearly is that if you are providing some NX-tomo, then you should access all the tools that we are providing, which is a big interest. And the idea is also that from this, scientists could use other tools that you are producing. So as I said, now acquisitions are done by Bliss, which is a huge improvement. And now they are saved as generic Nexus files. So this means that this is agnostics of any techniques. It will be the same for the moment if it's spectroscopy, diffractions, or tomography. So we need to go one step further and basically do some mapping, like users define where the rotation angles are, which dataset should be concatenate and things like this. And at the end, we get the NX-tomo to be reconstructed. This is also a nice interface to ensure some backward compatibility, because we still have some old spec acquisition that we want to reconstruct and also check PyHST versus Nabu, for example. And some beamlines are still on EDF. So this way, they can access also all the software that we are providing. The last point is regarding data exchange file format. I guess some of you know about it. So at the European Synchrotron, we have scientists which are using this file format, which is also based on HDF5, and it's the same idea. They can easily convert from data exchange file format to NX-tomo and benefits from the software. There is two kinds of interface for the users. Okay, sorry. First, it's a Python API. So usually you have one class to define the configuration you want to do. So provide input file, output file, dataset location, etc., etc. And then you will have one function to call, and it will produce one or several NX-Tomo according to the input file. And there is also a command line interface that you can access the same way, like provide some options or a configuration file. Last point that can interest some of you, it's also include some kind of helpers for NX-Tomo, because some scientists had issues by editing an NX-Tomo, like setting the energy or things like this. So we created a Nexus module inside. It's, for example, useful for a virtual dataset that we are using at the ESRF. And okay, sometimes it's complicated if you want to edit those. Okay, so there is a link where you have a notebook where basically you can construct from scratch an NX-Tomo. Then let's move to the core of the processing, which is NABU. And NABU is clearly targeting high-speed processing and having something very modular in order to create different pipelines. So it has been clearly tailored to ESRF needs. This is why we didn't take an existing solutions. There is many features which were not available somewhere else. Clearly, the reconstruction part, so the filter out bad projection, is really a limited part of the pipeline. We also needed to ensure legacy formats and methods from PyHST2. So this is several reasons. And we also need to create quickly some prototypes for scientists to test ideas and things like this. So this is kind of the constraint that we had when we started NABU. Then it's a set of high performance building blocks, as I said. And with those building blocks, we are creating pipelines in order to treat specific use cases. So the first one was the fast full field reconstruction, which is in production now, several beamlines at the European Synchrotron. One which is ongoing, but Pierre is highly working on, it's a diffraction tomography. It's a diffraction tomography. So it's, I think it's almost done, is implementing some feedback from the users. And then what's next, I would say it's the fluorescence tomography. So maybe next year, okay, we'll see, but that's one of the next items to take up. So here you can see an example of the full field pipeline. So basically it's different blocks like reading data, doing flat field, filtering, etc. I'm really having issues with this one, sorry. So it's to give you an idea. And all those steps, all the main steps, I would say, FBP, etc., or flat field are done on GPU. And CUDA, it's clearly the first target that we have, but we also have some CPU backend for testing, for example. So if really you don't have GPU, but the first target is GPU. It's also embed several estimation tools like alignment, center of rotation, which is usually a bottleneck, overlap for phase retrieval, etc. And there is also one nice feature, which is that you can save checkpoints at some steps. For example, if you want to play with rings removal or normalization, you can create a first reconstruction and say, I want to dump basically sinogram or some other steps and resume from this point. So sometimes it can be useful if you have a lot of iteration to do. Then last slice on NABU. The idea was clearly to get a low barrier to entry, because sometimes it can be complicated if you have to create intermediary classes or things like this to access the core functions. And basically, we are operating directly on NumPy arrays and PCUDA arrays. And it's focused on the core business, which is tomography. We don't want to go around, I would say. Here, it's just a simple example on the script on how you can access several of those blocks. So here you have basically with imports something like 40 lines, and then you can do basically read data, do a flat field, Paganin, then the reconstruction, and get the reconstructed volume. It's just to give you an idea of the design and how you can access it. But the expert of this, it's more Pierre. I don't want to give some wrong information. Then last point, it's on tomware, so which is basically the simplest way to see it. It's provide an interface to let users define their processing workflow. And instead of speaking too much, I will show you a short video. Okay, I allow it. And okay, I need to share, sorry, up the screen again. New share. Yes. Well, in fact, that's not this one. Okay, so everything is available on Linux. And then here I will just go for tomware canvas. Okay, you might not see it, but basically I launch the canvas. Then it will open this canvas, which is provided by Orange. I guess some of you know, but that's basically some add-ons to Orange. And then on the left, you have several widgets that you can interconnect together, like controlling the flow, basically, so providing NXTomo, for examples, calling some reconstructions algorithm, displaying some volumes or data sets, submitting some job to Slurm, or editing some NXTomo parameters. This one we need to add more things here, or directly input some Python command that you want to launch. And here, this is the simplest workflow basically that we can do. On the first one, we will provide data sets. On the second one, we will compute dark and mean dark and flat, mean, and flat. Then we will compute the center of rotation. Then we will call Nabu to reconstruct one slice in this case. And then we will display the result. Here, okay. Why did it stop? Here, I will simply drag and drop one Nexus file which contains one NXTomo. And I will process it. So yeah. Okay, so the dark and flat was already computed, so that was it was very fast. Here I select one algorithm between the one which Nabu is offering, and I launch it. If you can find it from the possible algorithm, you still have a manual fallback solution where you can shift one image compared to the others. Here we are happy about the center of rotation, and then we will call Nabu. It's the same. Nabu has its own basically graphical user interface where you can define, I would say, classical things like I want Paganin or not, I want to get output as HDF5 or EDF, or having some ring removals, etc., etc. And when it's finished, you can access it. You can access the slice directly here, which is the bamboo, which was the data set that we had on the first slice. And then you have some remember of what were the different settings. You can browse it, get some profile. It's a select window for the one which know about it. So you have kind of default tools, I would say. And that's it. You can also for sure go for the volume and things like this. I will just go back here, then you share. So if you want, there is also links to all the tutorials we have, which will provide you almost all the features that we have in tomware. Okay, I already spoke about it, but two interesting features. It's like users can directly insert their own Python script and do basically whatever they want with it. And it can also be triggered directly by Bliss, saying, okay, I have this data on disk, convert it to NXTomo and launch the workflow. Everything can be automated. Like when you define the algorithm and things like this, you can lock the value and it will run without the interaction. It's rely on a lot of software, but I also want to highlight like Silex, eWorks. There was a talk about vote on this. So this also rely on eWorks, Orange, H5Pi, etc., etc. Then let's slice about the futures. What do we want to do? I guess we have the same plane, like adding fluorescence, multi-phase, also ensuring more connection with other software like PyMCA, for example. Handling also more complex data, like now the work that we are doing, it's allowing to stitch projections and reconstructed volumes. We might integrate also some machine learning. This is Nicolas, which is looking into it for denoising. There is several contributors. I hope I did not forget any. So we want to thank them. And for sure, I forget friendly users, but we are lucky to have a lot of friendly users which are providing very nice feedbacks and helping us to find bugs. And last point, it's that we are hiring at the European Synchrotron. The first position is to work on NABU, and the second one is on current X-ray imaging. So if you are interested about imaging at the European Synchrotron, well, you might be interested about it. And yes, an important point is that this talk was also given on behalf of Pierre Paléo, that is the one in charge of NABU. So if you have questions of NABU, ask, but I might not know all the answer about it. And thank you, you have links. It's everything is under MIT license. It's open, do what you want with it. And if you have questions or if you have data set to try to reconstruct, let us know.
Thank you very much for interesting talk. Any questions? But why do you not join forces with the multi-imaging team?
That's a good question. I think that was this kind of first items. Like for now, I think we really want to keep control on the database to be able to create some quick prototypes and things like this. And the imaging part, I was aware of non-TIB only. The imaging, to be honest, I was not aware of how it was. I just consider it because yes, I guess there is a lot of common things. I think it's quite hard to let this core part kind of go. Yeah. Yes.
To answer to Mark, the previous tool, the mounted imaging tool, was relying on ASTRA, which is GPL licensed, and we would like to have something that is more friendly. So we couldn't start on the ASTRA tools. That's the name of the
Yeah, okay. Thanks.
Any more questions? If not, we can try to speak.
Thank you.